Today, we're going to break down a safety procedure that isn't just some rule in a book. It's a literal lifeline for thousands of workers every single day. It's called Lockout/Tagout, or LOTO for short. And it's really all designed to answer one crucial question. What happens when one person, maybe just for a moment, forgets a single step in a critical safety process? Well, the consequences can be absolutely devastating. Let's look at a real-world example of why this procedure is so important. And this isn't some hypothetical. This is a summary of a real incident, one that was actually investigated by OSHA, the U.S. Agency for Workplace Safety, and it just perfectly illustrates what is at stake. It all starts with a totally routine task. A maintenance worker is servicing a conveyor belt. But here's the thing. There was one critical oversight. The machine's power source was not physically locked out. And because that equipment wasn't locked out, a coworker, who had no idea maintenance was even happening, started the machine. In an instant, the maintenance worker's hand was caught, leading to a life-altering amputation. Now, this was not a freak accident. It was a complete and total failure of process. The investigation found there was no training, no written procedure. They didn't even have a lock to apply to the machine. Each one of these failures is exactly what the Lotto standard is designed to prevent. Okay, so that tragedy really establishes the why. It shows you the stakes. Now, let's dive into the solution, the system that acts as a lifeline to prevent these exact kinds of events. At its core, Lockout/Tagout is a set of procedures that make sure dangerous equipment is properly shut down and physically cannot be started up again until all the maintenance or service work is totally finished. You can think of it as a physical barrier against human error. At the very heart of Lotto is this idea of controlling hazardous energy. I mean, look at this. A lock on a high-voltage panel like this isn't just a lock. It's a shield. It's physically preventing an unexpected startup or the release of deadly electrical energy. The purpose here is crystal clear: to prevent the most severe, most devastating types of workplace injuries. We're talking about amputations, just like in the story we heard, but also crushing injuries from heavy machinery, electrocution, and severe burns. You know, a successful Lotto program isn't just about locks and tags. It's about people. OSHA actually defines 3 distinct roles, and it's absolutely crucial that everyone knows exactly what their part is. So let's break it down. First, you have your authorized employees. These are the mechanics and electricians, the people actually performing the lockout and the maintenance. Then you have affected employees. These are the machine operators who need to understand why the lock is there and that they must not restart the equipment. And finally, you have other employees, anyone else in the area who just need a basic awareness and to understand that they must never, ever touch those locks. All right, so we know the who and the why. Let's get into the how. What does the actual process look like? Think of this as the playbook for safely controlling hazardous energy. Okay, first things first, we have to understand what we're even trying to control. Energy isn't just what comes out of a wall socket. A machine can be turned off, but it can still hold on to dangerous stored energy. Like in this diagram, hydraulic pressure can just be sitting there in a system ready to move a powerful component without any warning. And hydraulic pressure is just one example. Hazardous energy comes in all shapes and sizes. It can be electrical or mechanical, pneumatic, like compressed air, thermal from heat, chemical. It can even be the simple force of gravity on a part that's suspended in the air. A proper Lotto plan has to account for all of them. Now, to control all that energy, the procedure has to be followed in the right order, every single time, no shortcuts. First, you notify everyone, then shut down the equipment, isolate the power source, and apply the physical lock and tag. After that, you release any stored energy. And finally, and this is arguably the most critical step, you verify that it's at a zero energy state, usually by trying to turn it on to make sure nothing happens. To do this, of course, you need the right tools. For electrical hazards, a breaker lock like this one physically clamps onto a circuit breaker while it's in the off position. There's just no way for anyone to flip that switch without removing the lock. So what about things like pipes and valves that are carrying pneumatic or hydraulic energy? Well, for that, a valve cover completely encloses the handle. This makes it physically impossible for someone to just walk by and turn the valve, re-energizing the system. And you know, not all equipment has a simple switch or a nice round valve. For the larger or more awkwardly shaped controls, a versatile cable lockout can be used. You just loop the cable through, pull it tight, and lock it down. It's a really adaptable solution for complex machines. But what if you have a whole team of people, say 5 people, all working on the same machine? That's where a group lockbox comes in. It's a pretty brilliant system. The main key for the machine's disconnect is placed inside this box. Then, each worker puts their own personal lock on the outside of the box. The box can't be opened to get that key until the very last person has finished their work and removed their personal lock. It's simple, and it keeps everyone safe. When you see all these tools and procedures, it becomes pretty clear that Lockout/Tagout isn't just a suggestion. It's a real commitment, one that involves everyone and has really defined responsibilities for both the company and for every single worker. The employer, they have to lay the foundation. That means developing the written program, providing all the right locks and devices, training every single employee on their specific role, and then doing annual inspections to make sure the program is actually working. And the employees? Well, they're the final and most critical link in the safety chain. Their job is to follow the procedure every time, to always verify zero energy, and to live by two absolute rules. Never, ever bypass a lock, and never, ever remove a lock that belongs to someone else. You know, the locks, the tags, the procedures, it's an incredibly effective system. It's almost foolproof. But it all hinges on one variable that no piece of equipment can ever replace: the trained, focused, and committed worker. That's the one variable you can never, ever forget.